Hello all, welcome back, and today's discussion is about merge chart. So here merge chart is another example for divide and conquer algorithm, and in this video we'll discuss what is merge chart, and we'll discuss about the algorithm of merge chart. And coming to merge chart, so the name itself says it is a sorting technique. So where we are given with n elements and we need to sort those elements in an order, like any ascending order or descending order. So here the general idea of this merge chart is when n number of elements are given, we need to split those n elements into two sets, that is two equal halves, that is from a of 1 to a of n divided by 2, and then a of n divided by 2 plus 1 to a of n. So this is how we are going to perform merge chart by applying divide and conquer, that is n elements are divided into two equal halves. Again after that we need to subdivide the elements once again, so until we find the minimum number of elements in the list. So once we split all the elements until we reach a certain element in the list, then we are going to compare the elements and then we'll be merging those elements, and then finally we'll obtain the solution. So this is how merge chart works by using a divide and conquer algorithm. Here is an example given. So you can see n number of elements are given, that is totally 6 elements are given here, and all these elements are in unsorted order. So since this is merge chart, we need to sort these elements by applying divide and conquer. As I said, there are 6 elements here. We need to split these array elements into two equal halves. So here 7, 6, 1 and then 5, 4, 3, which is 3 elements here and 3 elements here in this array. Again what we are doing is we are splitting this subarray, like having 2 elements in the first array and 1 element in the second array. The same way this is also gets divided into 2 halves, and again coming to this one, this will get divided into 2 halves. So same way 5 and 4. So in this way we are dividing the given elements, okay, so until every array contains single element into it. Now so this is divide. The next is the conquer, that is we need to compare these elements of array and then we'll be combining the elements one by one, and finally we will obtain the solution. So here is how the combine is happening. If you look at here, so we have two different arrays 7 and 6, and when you are combining these two array, okay, so these two get sorted first and then it is placed in the array in the order. And same way here, if you take the other value 1 and this one is compared with these two values of this array, then it will be placed in the array in a sorted order. Same way in the right hand side. So this is how merge chart works. And at last you can see the final solution here. Now we'll discuss the algorithm for merge chart. So here is an algorithm given. So I'll take the same example which we have seen previously, and we'll discuss how this algorithm can be applied. And if you look at this algorithm is mainly focusing on dividing the problem into sub problems, okay, and at last we are going to combine the solution, and for that we will have some other algorithm, okay, that will perform a different operation for combining the solutions. And here you can see we have a recursive calls here, that is merge chart. So this recursive call is for this like algorithm call where we are going to divide the sub problem by this recursive call. So we'll see how this recursive call works here. So first we'll start with this condition, that is low less than high, okay. Only if the low value is less than the higher value, then we are going to proceed this step. So what is the low value here? My low value is 0, which is the first index of the array, and here high value is the last index value of the array. Since we have 6 elements here, low value is 0 and high value is 5. So once the low value is lesser than the high value, which means you have more than one element in the array. So you need to split that array then, okay. So for that reason, first you need to find the mid value. When you want to split the array, first we need to find the mid value, and that can be found by the formula low plus high divided by 2. So in that case, now what is the mid value? So the mid value will be 0 plus 5 divided by 2, which is 2.5. So here I am going to take the floor value, okay. And if I take the floor value, my mid value will be 2. So here what is the value 2? This is the value 2, that is 0, 1, 2. So now I am going to take this as a mid value, right? And then I want to divide this array into two sub halves. So how we are going to split this array into two halves? So the first array will be containing 7, 6, 1 and the next array will be having 4, 5, 3. Now this 1 is my mid element. Right, so how am I going to divide this array? So the first array contains low value and then up to mid value, and my second array contains what? Mid plus 1 value and then high value. So that is what given here. You are going to divide the sub problems, and in the first recursive call you can see I am passing an array. With that, what is my low value? Low value is same low value. And what about my high value? In high value, now this mid value is my high value in this sub array. So I am passing this mid value. And coming to the next recursive call, which is at the right hand side. Okay, so this is the next part. And in this, what is my low value? Low value is mid plus 1, which is 5, right? So mid plus 1 is my low value in this array. And what is the high value? High value remains same. So high, I am taking it as high only. Okay. Now again, how this call works recursively means, so once I split this array, okay, I found out my low value and I found out my high value. Now this is my low value and this is the high value for this sub list. Okay, 0, 1, 2. So 2 is the high value for this sub array. Right, now what you're going to do, again you're calling this method, passing this low value as low and passing this mid value, that is high value. This is the mid value now, right? So this will be taken as a high value here. Okay, now the value of low is 0 and the high is 2. Right, again it checks for the condition. Yes, this is true. If this is true, again you need to find the mid value in this array. So if you find the mid value in this array, now this 6 becomes the mid value in this array. Okay, so in this case, again what you are doing, you are calling this method again once again, okay, by passing the value. What all the values you are going to pass? So low value, my low value is again 0 for this array. And what will be my mid value? So this will be my mid value, right? So this I am going to pass. So again what I am doing, I am going to split this array into two, which contains 7 and 6 in the left hand side and 1 in the right hand side. So this is how I split. Now this is my low value and my mid value is my high value. I am passing this as a high value. Again this will be passed here. This calls this method. Okay, once again it checks the condition, it will find the mid value, again it will divide the sub problem. Then my sub problem will be 7 and 6. Okay, so this is how the recursive call is happening. So first this recursive call will happen and all the elements at the left side gets divided first. Okay, after that it comes to this next part, that is second recursive call. So this second recursive call again works here like this, and then this will get divided into 2 as like we did in this case. So again this will get divided into 2. Okay, so this is how these two recursive calls works in this algorithm. Okay, this is for splitting the given array into sub array. Now coming to merge. How does merge works? Now coming to the algorithm merge. So if you look at this algorithm, here we have two arrays. One is array A and the next one is array B. So what does array A contain? From the mid value to low value, and B contains high value to mid plus 1 value. So coming to this array A and B. So I'll take the same example where we subdivided the given problem. And at last the array contains a single element in it, right? So I have taken the same example here, and this is my A array and this is my B array. Now I need to perform combine. Okay, so while I'm combining these two values of the array, what I have to do, first I need to compare these values, then while combining I need to combine it in the form of sorted order. Okay, so for combining I'm going to take a new array, okay, and then that new array is called as C. right? So now I need to compare this value with this value. If I'm arranging the elements in ascending order, so always I need to check whether my A value is lesser than B value. If A value is lesser than B value, then I need to place this A value into this C first. Okay, otherwise if B is lesser than A, then this B value should be placed into this C array first position. This is what my condition. So that is what I am doing here. Here I have initialized all these values I, j, k, and these values are the index values for my arrays. So for A array I am taking I as the index value. For B array j is as the index value, and for C k as the index value. So initially all the index values are 0, right? Now A contains only one element and B contains only one element where their index values are zeros only. Okay, now you are going to compare same whether my A of I is less than B of j. So what is I value? 0. What is j value? That is also 0. We initialized all these with 0, right? Now what you are doing, you are comparing the first value with the B value. So A lesser than B. So if this condition is true, you need to place A value into Cth position. But what happens? This condition is false. If it is false, coming to the else block. So if this condition is false, obviously B will be the smallest value. So you need to place this B value into C. Now Bj, that is B of 0th value, will be placed into C of 0. Okay, now what will be the first position value of C? That will be 6, which is in B, right? So we compared these two values and we have placed that smallest value into this new array C. Okay, but our process didn't stop here, because we are going to combine these two values. We just have placed only one value into the C. We need to copy the remaining value present in the other array, that is A. So if you want to copy this array, again you need to write the code, right? So for that only I have written two for loops here. You can see two for loops. Okay, so in this for loop you are just copying the elements of A into C and elements of B into C again. So which elements you are going to copy? Whatever the elements that is left in the array. Okay, so among these two arrays we compared with these two values and we placed 6. Now what is left here? This array is left. Okay, we didn't place 7 in this array. So you are going to place this value 7 into this array here by using this for loop. Okay, whatever the values that is left in the 8th array, that will be copied to the Cth array. Okay, and you can see every time after copying, the index value of k is getting incremented every time, right? The index value k is getting incremented every time. So one value is getting placed into this, again the index value gets incremented and moved to the next position. So if you have one more element in this array A, that will also be copied to the Cth array in the next position. Okay, this is how the merge happens in the merge sort. Okay, so how does the merge sort, that is how the problem is divided into sub problems, that is what the first part of the algorithm, and the second part of this algorithm is about how we are going to compare and how we are going to combine the solutions. Okay, in this way you are going to combine the solutions. And the last is the time complexity of merge sort. So how do we find the time complexity of merge sort? As we know, when we are going for divide and conquer, we can find the recurrence relation for that algorithm, and based on that recurrence relation, so we can find the time complexity of an algorithm. So when we are having divide and conquer recurrence relation, we can apply Master's theorem for that particular recurrence relation and we'll find the time complexity easily. So coming to the recurrence relation of merge sort. So this is the recurrence relation for merge sort algorithm. So here this value 2 represents each time we are dividing the problem into two sub problems. So that is why this 2 is given. And coming to T of n by 2. So n problem is divided into half, right? So n divided by 2. So the time taken to divide the n problem into n divided by 2. So that is totally given as 2 into t of n divided by 2. Plus here n minus 1 is the time that is taken to merge the sub problems. Okay, so we are comparing and merging the sub problems, right? So that will happen in the time n minus 1. So when we apply Master's theorem on this recurrence relation, then finally we will get this big O of n log n as the time complexity for merge sort. So this is the best time complexity, worst as well as the average time complexity of the merge sort algorithm. Thank you.